Okay, geographers, my little spatial analysts, I'm going to talk to you today about mapping quantities, or as ESRI slash Esri, whatever they're calling themselves these days, as they like to say, mapping the most and the least. But I don't know. I think that sounds kind of childish in that we're mapping quantities, which, yes, I guess. I mean, we're looking at, okay, the most of something, the least of something, but also people who are, or whatever, data, I should say, that fall into average, right? They fit the average, or they're in the middle somewhere or something along those lines. This is incredibly important. It's simple, and which is why we kind of start with some of this stuff, or at least the concept is simple. But what I want to point out, and this is a problem that we don't point this out enough, what I want to point out is that despite its simplicity, there's a lot that goes in here, things that we need to be thinking about as GIS people, as we start doing this spatial analysis. You want to be going through and just kind of asking yourself, first, am I doing this properly? What am I really doing here? What am I showing? Am I misleading my audience? Am I making a mistake? That's what we want to think about. And so to start with, before we get into any actual GIS stuff, what I want to do is show some, well, most of them, some maps that aren't doing that great. And we see a lot of this stuff with COVID-19, which is, spoiler, that's when I'm recording this stuff, is in the midst of the COVID-19 pandemic. We're a good year into it. You can see the date down in the corner, right? And then I'm recording this stuff. So it's been a solid year that the United States has been a disaster. So I thought it'd be good to look at this stuff, to look at COVID maps, as well as data, and play around with that a little bit to get into how we display some of this stuff. So this first image, I pulled these things from Google. I don't have any actual source stuff for this specific image. Doesn't really matter because I want to point out more aesthetic things and general things. We're not trying to derive information from these maps so much as think about the act of making these maps or presenting these maps. And this one, well, there's a real issue with this, and I'll let you think about it as we move forward here. Feel free. Maybe I'll try to do this where I say, hey, look at this one, and you can pause the recording here and you can think, okay, what's he gonna point out? Right? Maybe you'll figure out what I'm gonna say. Maybe you'll figure out even stuff I'm not even thinking about. Who knows? But with this, or these three maps, so it's good that we're getting this time series, right? Where so it's trends in new deaths per 1,000 people. So that would be a death rate. And so this, we're gonna get into, or I'll talk about some different types of displaying data, but we'd call this ratio data. That's our level of measurement as we're doing this. Well, we're not just showing the raw number of how many people died, and it appears to be by county. This is, again, I found it on Google. It's kind of it's a tiny little image here. We'll do the best we can. I'm assuming it's based on United States counties. And so what they're doing, rather than show just the number of deaths, they make it this rate, right? You take that number and you divide it by, the total population, right? To get a sense of how many people are, or what that rate is versus just, how many people live in a place. Like California, you're going to have more COVID deaths simply because we have more people. Right? And like Texas and Florida, some of these more populated states or counties or whatever. All right. But to make it in this ratio, that helps us actually compare people. We're breaking it down to, for every 100,000 people, this is how many deaths actually occurred. And so we can compare across state lines, and we can get meaningful information from these very populous counties and these not so populous counties. Does that make sense? Okay, so that's good. Good how they did that. The problem, though, is we ain't got no legend, right? I mean, we can look at it, and I can look at red, and red is scary and angry. And so I assume that those bright red spots, that's where there are deaths galore. All right, but we don't know. Is it, 99,999 deaths in the red per 100,000, or is it, 17, right? Is that the max, and everything else below that is lower? We really don't know. Now, that it could be that the legend was a separate image, and so in my Google search, we can't see it here. I don't know, but it's just one thing. When we are mapping quantities in this way with these Choropleth maps, and I don't even know if I said that yet. Choropleth, it's a fancy term, a map term, which is what we're looking at right here. It's where we take some data, in this case, COVID deaths, and we map it using fixed geographical boundaries, all right, places. So in this case, United States counties, right? So it's the idea that we're tying these deaths, we're recording the data, not just the deaths themselves, but we're connecting them to in which county did these deaths occur, right? And that way we're able to lump all that stuff together, map it based on the county. We get a number. There are, 5 deaths in this county, 10, 20, whatever it might be. And we can do our death rate math in here as well. And so we're able to map the information, but tie it to a fixed place. And that helps us visualize it. And it helps the idea with any of these Choropleth maps is what we're trying to do is tell a story with the data and do so in a visual way. So the goal is you should be able to look at any of these maps and you within, a moment of glancing at it, you go, oh, I see what's going on, right? So that's the goal. And we can do that with this. We can get a sense of what's happening. But what you then need is to have a legend, have some more information so that once we get that initial sense of what's going on, we can step back and we can go, okay, wait a second. Let me ask this like I did, what does that bright red actually mean? Is it apocalyptic or is it, it's the worst, but it's still not so bad, right? That's what the legend would be for. That's what we want to have. So that's one issue we see with a lot of this is that these legends aren't being freely given out with various, news media, whether it's stuff you see on TV or online or in a newspaper or wherever. It's not as clear as it could be. And we see that is important. And let me go to this next tab here. So this is something that was brought up over the summer. And it's the case of Georgia. Georgia, it sounds like, has had a rough go in terms of mapping this stuff and getting information out to the public. There are multiple stories I've seen, and I haven't done enough to really, research it and get a sense of it, mainly because I don't live in Georgia, don't have family in Georgia, so I've been paying attention to, California. But it sounds like they're having a rough time. And this came out, I think it first showed up on Twitter. Somebody grabbed these screen captures of one of these dashboards. And the term dashboard is just, it's a buzzword kind of thing where a lot of states and different agencies are mapping things. And they give you a little power, capability to go in and tweak stuff and mess around with stuff. But it's a way to get information out to the public. That's the general idea. And so what we see here, if you just look at the maps, cases per 100,000, okay, again, we're doing that ratio stuff, so that's good. We've got July 2nd, July 22nd, we've got the legend down here. All so far so good. But when you look at it, you see, okay, it doesn't look that bad. We have this one county right here that got a little bit worse, throughout the month. But everybody else seems more or less, it doesn't look scary, right there. Now, if you start to really look at it, you can see, okay, some of these that were lighter are getting darker, and that's an easy visual cue, and that's something to think about as you are making these maps. Our brains just work, it seems to be, and this is, I don't know if we can say this is a universal thing, if it's an American thing, a Western world, whatever. But what we tend to assume is when we see lighter colors, we imagine less. When we see darker colors, we imagine more. All right, which is what this map scheme is doing. And then to show the real extreme cases, they have the bright red, which is also a good thing to do if you want to point out, where the problems are or where the real extreme outliers are. You can do that. You can do a totally different color that stands out, draws your attention to stuff, right? So that works. So far, so good. The problem, though, with this is that we're comparing two of these Choropleth maps, but we shouldn't, all right? And you can tell we shouldn't when you look at the legend itself. So this first one, none. We've got none here, fine. And it honestly, it looks like that's not the case at all in Georgia. So that's almost kind of useless right there, just gets in the way. But then we go to this next one. We have anywhere from 1 case to 620 cases gets this light blue. All right. But over here, it's from 1 to 907 cases gets the light blue. Right? So if we're comparing it, that's great, but we just kind of assume light blue here means the same thing as over here, indicating no change. But in reality, what's being displayed over here is, not so big a deal. It actually would fall into this category over here, right? You see that? I hope that's clear as you're looking at it. And even these extreme cases, we go all the way to the end, right? It starts at 2,961 over here. Over here, it's 3,391. So if we mapped this using the exact same legend, the exact same classification scheme over here, we would most likely get a totally different idea of what's going on. All right, hopefully that makes sense. And so that's one warning thing, that not only, yes, we need to have our legends and everything, technically speaking, if we looked at these maps individually, we could say, yeah, that's a good Choropleth map. It's giving a sense of what's going on. It's telling a story with the data. But then the issue here is putting these two next to each other. That's a problem. You cannot do that unless you do some stuff, which I'll get into. I'll show you some of the practical things here, but you need to be aware of what it is you're doing. But the general idea is these legends have to be the same. The classification has to be the same. All right. Now with this, you could think, and I think the original thing I saw, that Twitter post, was it made it look like, those bastards in Georgia, they're trying to trick us. It's like the man trying to keep us down here and not let us know what's going on and all of that. Look, I'm not gonna lie, that could be true. That's not shocking. In fact, we'll talk about the poor GIS analyst in Florida who got fired or removed from stuff for that very reason, at least allegedly, I think. I don't know all the details here. Please don't sue. But it also, what I'm thinking of when I first see this is I think, you know what? No, this is probably a case of people not fully being aware of what you need to do to properly display this information. And if you read through here, as we go down, it's talking about blah, 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 blah. I mean, you can see the link up here if you want to go to it. And it's pointing out the kind of stuff that I just pointed out here. But I think, and the big issue was, this was, the reopening was being pushed. That was the real problem, is that there is this whole idea of reopening things, letting people go back out into the world around July. And so this was, showing that actually, no, don't do it because it's getting worse, right? We should be not going out. We should be staying home. So that was part of the issue here. But there's somewhere in here, I think, one of the people in charge of the data was talking about, God, I don't know. This is how prepped I am. I'm just playing around. You can read it. But it was the kind of person, the person who was responsible for this was saying, well, this stuff is being compared when it shouldn't necessarily be. And so it could be that, that person who found these original things and put them next to each other like this is the person who actually did the comparison, where the state of Georgia was never trying to make you compare this stuff, but it was the person trying to show the injustice who actually made it look this way, if that makes sense. But it's a case of the person or people or team who's in there mapping this stuff shouldn't necessarily use right here it's most likely, I don't know, not looking at the original stuff, but it's this natural breaks method, and I'm going to show you this stuff, of displaying the data. There are other classification schemes that could have worked where, especially if we're going into how many cases per 100,000, we could get some kind of percentage schema going or something along these lines, or having some kind of ranked system, right? So I talked about ratio, where we take one thing, we divide it by another thing to get some kind of, percentage or some kind of ratio in there, right? But ordinal mapping, right, or classification, this, again, it's called measurement levels. I don't know, somebody came up with these different measurement levels, but an ordinal system is where we rank it, right? So we could reclassify this. In general, we could have something where, none, let's ignore that, but we could just say, to keep it simple, we could say from 1 to, 500, right? Let's just say 1 to 500, we're going to call that good, right? Or maybe not good. Maybe how about not a concern, something like that, right? And so in the not a concern category, classification, rank, it would be that light blue, right? And then 501 to 1,000 could be troubling. I don't know. If somebody would come up, the marketing people would come up with stuff. And so that would be, troubling would get this slightly darker blue and so on. And we get down to the red, and that would be 3,000 and above, let's say, would be extreme, severe, terrifying, whatever we want to say in there. And then if it's the same throughout, then A, we get rid of some of these confusing numbers, and B, we can actually compare this stuff. We can say, okay, at the beginning of July, we had all these counties, were in this, okay classification scheme. And then they by the end of July, they moved up into the, concerning, troubling, whatever thing. Does that make sense? So that's ordinal. That's this ranking way. That's a way of comparing this stuff. That could have worked. Or, and as I'll show you, we could just, come up with, make it, do a manual break here, where we do have, like I said, 1 to 500, 501 to 1,000, 1,001 to 1,500, something along those lines, right? If the people in charge here did that properly, this wouldn't be a problem in the first place, right? With this comparison, where even if they didn't intend for it to be compared, you would have maps that average citizens could look at and actually compare, right? And actually start doing some spatial analysis, right? Even with just the JPEGs of the maps or whatever. Hopefully that makes sense. Hopefully this is clear. You following? Oh, okay. All right. So that's that. And actually, let's just click over here now that I mention it. So my main point with this is that it's not necessarily that the government is trying to be corrupt, be evil, mislead people. I've seen it enough. Hell, even done it myself, I'm sure, early on. Luckily, I wasn't doing this stuff in a pandemic. Wasn't quite as big a deal. But as you're learning these things, you don't necessarily know by default the best way to go about this. But then we have this story here. This was an exciting story, if for no other reason than there was a GIS person in some big scandal in the news. And one issue was the governor of Florida or some high up, I forget what he said, but he dismissed her as some, like I don't even remember what it was, but basically, I think they effectively said geography isn't science or something like that. And of course, all the nerds said, the hell, and got mad about this. But this woman, Rebecca Jones, who is definitely skilled, she's got like a master's in this stuff, knows what she's doing. She's making, has made accusations about being removed from Florida's dashboard, being able to get this stuff out to the public because she would not manipulate things, would not actually make it look less bad, right? Like it's no big deal. So we could open up and all that. And so what this does, and again, I have not, my God, this past year has been crazy. I haven't had time to follow all these different things that I've been interested in. So I don't know. I don't know if it's been proven that absolutely happened. I don't know if it's still in some kind of litigation thing or whatever. But what this says right here, even the fact that we could hear this story and go, yeah, that makes sense. I buy it. And believe me, I believe it. Having worked in a variety of industries and all that, and dealing with GIS data and getting stuff out to the public and not getting stuff out to the public and these kinds of things, I am not shocked to think about politicians saying, hey, no, don't show it this way. Do this other thing, right? Maps are really easy to manipulate in this sense. So that very fact that's, the case here, we do need to definitely question all of this stuff. So even though, and if I go back here, even though I don't think this was necessarily evil, it's still a reminder, whether it's evil or not, we need to question all of this stuff. And it's why learning GIS is so great, is that we can go in and we can mess with this stuff ourselves. All right, that's a beautiful thing here. And in fact, let's just go straight here. I had some other stuff. I'm going to skip it. I think we've talked about this stuff enough in here. But what I did was I just went to this healthdata.gov. I got some COVID-19 data. So this is coming from the U.S. government. They're gathering data and just putting it out in tabular form. So it's in a spreadsheet, and it's stuff that you can easily bring into GIS and you can mess with. Now, I'll say this is where this gets kind of funky too, because we can complain about, governors of states and different higher ups trying to get people to not display data in a certain way, or maybe it's those doing the analysis didn't have the best training or whatever, or aren't aware of the best way to get this stuff out there. However, it's set up here, great. That's kind of the end users of the data though, right? The other thing we do have to question is, do we trust what the government is giving us here, right? And I realize as I'm saying this, I'm alone in a room talking into a microphone, and it's very conspiratorial. Hey man, don't trust what the pigs are telling you, man. It's all fake and all a lie. I'm not saying that. I'm not saying that it's all fake and a lie. But what I am saying is, this isn't gospel. This isn't stuff that was brought down from a divine being that here is the truth, right? That's how we'll talk about this. This is not the truth. These are data that have been put into a spreadsheet. Okay. How the data were collected, I don't know. And we can dig into that. We can find this stuff, but we do need to remember these are being reported by people. And just like people can try to get you to not, display data in a certain way to make things look better, hospitals don't want to necessarily make themselves look bad, or they have a vested interest in, making sure that data is treated in a certain way. Just saying you want to be critical about this stuff. right? How is it getting out there, especially with native healthcare in this country where so much of it is for profit, or just the fact that money is involved in the way it is. We want to question it. All right, that's what I'm saying. But we're not going to question it totally. I want to show you how to play around with some of this stuff. Okay, that's the idea here. So let's go to the map. Let's pull this up. So what I have in here is a few things in here. And this should all be available through Canvas or however I'm getting it to you at this point in time as you're listening to this recording. But we've just simply got the U.S. states right here. And in fact, what I'm going to do, sorry, fellas, but I'm just going to get here to the contiguous United States. So it's a little clearer. Not to say that Alaska and Hawaii don't matter, but it's just aesthetics, right? And so I've got that. I've also got some of this precipitation stuff. It has nothing to do with COVID, but I'm going to show you some different stuff in here too. And then what I also did, if I click here, so just a refresher, if you're using Arc Map here, we've got the layers shown here. This is listing by drawing order, right? So, and this is, if you'll recall, you can click and drag and move stuff around. We've got, right, to decide what's drawn first and second and so on. If we click on here, this list by what data source, we can see tables. All right. And so this table here, what I grabbed was this back from here. This is the estimated inpatient beds occupied by state. Okay. So it's the idea, the whole issue with COVID, and one problem with reporting deaths is that, the deaths aren't that scary when you compare it to some other stuff. Like at the beginning, we had stuff like, it's the flu kills more people, right? And that was the idea, the flu. And early on, yeah, that worked. Now we can see it's worse than the flu, but still it is, people bring up other statistics. You're more likely to die in a car accident or, something like that. So we've got that. And it is a way, and you look at the percentages of people who get it and who die, and these numbers aren't scary, right? It's not like 60% of people who get it or people are dying from this thing or whatever. They're small numbers, but the reason why it is a concern is that really, like so many of these things, it gets back to our own political, societal issues. It's a human problem because our healthcare system has been taxed so heavily by this, right? Hospitals are filling up and people aren't able to get the treatment they need to save their lives because we're out of beds or ventilators or whatever it might be. I mean, there are some real horror stories. That's one benefit of having a spouse who works as a nurse in a hard-hit hospital and has been dealing with COVID patients and seeing this and all that, is I get the horror stories. And that's something that people who aren't connected to hospitals in this way aren't necessarily getting, is the stories of how bad it has been in the hospitals and how many deaths could be avoided if we had, more beds and nurses and people who are able to deal with this stuff. And also keeping in mind too, this is my little preaching corner, but it's not, let's say you don't have COVID, but you have a heart attack or you get cancer or you have something else, right? You're also going into this place where it's heavily taxed. Not only might you be exposed to COVID-19 and have issues there, but you're not getting the attention as well. That's the big issue. So that's why I pulled this stuff down, is we're going to look at these, displaying how fully maximized these beds are across the states here. Okay, so to do this, just a little refresher, because I'm sure you guys have forgotten since you took your 205 class and all that. But we're going to join this estimated inpatient thing right here to this table, right, to this state thing. And so to look at, if we open this up, just right click, open. We've got a whole host of things in here. Let me make this bigger so we can see. So we've got the state in here. And if we scroll down, you can see it's done by the abbreviation. So California is CA. That's important for our join, right? Collection date, inpatient beds, occupied, estimated count, LL, count, UL, some different things in here. If you're not sure as to what these numbers actually mean, what you need to do is go back to that website, okay, and find some kind of metadata, right? Get in here. There should be in here something that tells you exactly what's going on. And if it's not clear, you track somebody down, right? To make sure, especially if you're actually using this to, try to prove a point, to try to get information out there, you want to know what LL means, what UL means, what some of this other stuff means. Because I'm just trying to show you this stuff. We're just going to go through. We're just going to map some stuff. But I definitely wouldn't be, producing this, getting this out to the world if I didn't know what all this stuff is. Because really, for me, one good thing that's saved my career, I'm sure, is I live in constant fear of someone, whether it's one of you students or it's a member of the public or whatever, like depending on what I'm doing, it's somebody saying, hey, what's this mean? Referencing something I've done. And I go, yeah, I don't know, and look like a dummy, terrified of that stuff. So you want to go through and know everything about this, and that'll help you not look like a dummy, right? Not be embarrassed, very vain reason to do it, but it'll also make sure that you're using the right things in here, right? The right numbers, the right fields, and so on. But what we want to look at is this state value right here. And let's see, we also have, what's important to realize too, is we do have this time series thing in that this is, we have multiple dates. So if we're joining in here, it's gonna pick the first California that we have, match it to California. But is that gonna be, for the third? Is it gonna be for the fourth or whatever? We'd want to know that. So what we can do is we could do a select by attributes query in here, right? Say we want everything for the fourth, right? Everything for the second or whatever. And then, in fact, let's do that. In fact, no, you know what I'm going to do? Can you tell I'm making this up as I'm going along? Let's do the join first. Right click on state. All right, if you're doing this, joins and relates, join. I'm going quickly because you guys can pause this. Because in theory, if you're in my class watching this, you should have already completed Geography 205. Joins and relates should be no problem. But B, you can stop it, pause it, rewind it, and so on. So in here, and what I would have checked too is that we have the state abbreviation. Okay, so that's what I'm going to make this join based on, because this will have, for California, it'll have CA. And in our table here, state, it'll have CA, and it's going to match stuff. So let's hit OK. And what's always great is if it works, nothing happens. And if it doesn't work, nothing happens. It doesn't say, hey, everything's cool, right? Instead, what we have is just this, and we have to see what's going on. All right, so let's click on little identify tool, that blue circle, the white eye, just to make this fast. So we can click on this, and all of these, this is all census stuff from the census that was already attached to these shapes. But if we go down here, we've got, this is what we joined right here. So that's state, CA, collection date, January 20th. Okay, so that's important, and we've got all this information. If it didn't work, it would say null, if you recall, and that would mean I picked the wrong thing. I didn't match it properly. That join didn't work. But if I see values in here, fantastic. And let's just see, are these all for the 20th? They are. So I'm guessing it went through and grabbed, okay, that 120 right there, right? So they all look good. All right. Okay, great. So we've got for January 20th. So we're going to start with this. Now, what I can do, in fact, let's do it this way. I'm going to right click on state. I'm going to go into properties. Okay, now right now, it's displaying this with what we call just a single symbol thing. Everything's blue. It's just this blue. And yours might be, if you're bringing this in and playing along at home, yours might be some other terrible pastel thing. They just kind of randomly assign this stuff in ArcMap. But it's where we're not differentiating anything. We're not mapping quantities, right? At all as we're going through this stuff. It's just, hey, here are the states. We're treating them all as the same. All right. Now, as we go through down here in this symbology tab, we can go down to categories. And what categories is useful for is for what we call nominal data. Again, going to our levels of measurement. So nominal means that everything it's different, but nothing is more or less than anything else, right? So in the case of state names, like if you're looking at a political map, we could do this. If I do this here, let's hit apply, right? We've all seen maps that look like this. They're just, the colors are different, so we can easily distinguish the difference between the states, right? Between, Utah and Idaho and Nevada and all that, right? That's the idea. That's nominal data. That is not good for mapping quantities because, again, it's not saying anything about, like back to our COVID stuff, we're not learning anything from this other than we know that we have different states, right? It's this quantities right here. That's the useful thing. Okay. Now, within this, though, while this is useful, remember always that the computer is dumb, right? ArcMap is dumb. All of this stuff is dumb in the sense that it's not thinking for itself, but it's allowing you to do things. But you're the brain behind this, right? You have to be able to pick, what's the best way to get this stuff out there. Keep that in mind, right? It will let you do things that are horribly stupid because the computer's stupid. It's not checking your work and saying, whoa, are you sure this is the best way to get COVID-19 information out there? No, that's why you're in college. That's why you're learning this stuff, right? So just keep that in mind. Just because you can do this in here doesn't mean it's the best way to do it. All right. So let's start with just graduated colors. So from here, we can scroll down and you can play around with this stuff too, because you can just do, population and the different census data that are in here. But again, we're going to do this with what we've got. And we're going to do inpatient beds occupied estimated. All right. So there are our numbers. And if I apply this, okay, and so what I've got here is it's just showing these beds, the raw numbers of how they're occupied. And you'll recall when I say raw numbers, that should be a big red flag. If we don't want that. Because if you look at it, what trends do you see here? He says, expecting you to talk into your computer. You see California, Texas, Florida, New York, the dark red, right? Indicating more. But that doesn't matter because, of course, there are more beds occupied in California, Texas, Florida, New York, because there are more people there and more hospitals there and so on. So this is meaningless, right? Same thing with a lot of these lighter colors. Of course, there are less beds occupied, less people there. That doesn't necessarily mean the disease is better or worse or any of that stuff. So we can do this, but it's misleading. That's a bad map. But if we did a nice legend and we had all sorts of stuff, we made it look really digital and shiny and nice, we could convince a lot of people, right? That this is not good. This is not quality work. So what we want to do is we want to use this normalization capability right here. And normalization, it's a whole thing in terms of data and database management stuff. And what I've heard, I don't know if it's true, I've heard it has to do with pot. That's what a professor told me, that it like normal, I think has a Y in it or whatever. It was like this hippie pro pot group from like the 60s or 70s or whatever. And a guy who was big on database stuff, he was also big on pot, which if you're taking the database class, I'll talk about how you almost need drugs to get excited about some of this stuff. But regardless, that's where this normalization comes from. But what we're going to do here is we're going to use this to get that ratio level of measurement, right? Not raw numbers. We're going to compare these raw numbers to something that's actually meaningful. In this case, total inpatient beds, right? So we've got the occupied beds, but we're going to compare that to how many beds are actually there. And what we're going to get, doing some division here, we're going to get a percentage, right? That's what these numbers represent here. Might not look like it right now, okay, but it is. And so what we'll do, let's fix that to make it, actually reflect what it is. If you right click on any of these things over here underneath label, all right, we do that. We go to Format Labels. From this category, we can come down here to percentage, and we need to make the decision. The number already represents a percentage, or the number represents a fraction. Adjust it to show a percentage. Which would it be? Looking at these, hopefully you're shouting fraction, because that's what it is, right? It's not 0.5874%. It's 58.74%. Right? You dig? You remember 8th grade math or whatever it was? And what we're also going to do in numeric options, what it defaults to, for whatever reason, it's so dumb, but it defaults to 6 decimal places, which it presents a level of precision that not only do we clearly not have in most cases, but we also don't need. We don't care about the 10,000ths of a percentage point in terms of beds. We're just going to go drop this down to 1. So these look like real numbers. Okay. So let's hit OK. Let's hit OK. And you can see, right? That looks more meaningful. And it also brings up an alarming 103.5%. The hell? And I don't know. This is where you would get this. You'd want to dig more into the data to make sure that's not an error, number one. But that could also mean, which we've seen here in California, a case of, the beds are full, right? So we've got people on cots and in other, makeshift things. We're opening up new stuff. It could reflect that. I don't know for sure. I wouldn't make a map and I wouldn't state that clearly until I actually got into the data, did some more research, but we could definitely do that. Okay, and here I'm going to hit apply. And so we see some changes now, right? We've got, California still pretty dark color in here, but you can see Texas gets lighter, New York gets lighter here. Florida's kind of the same shade as California, but we see the South, is raised up. We see some of these Western states got a little darker while others stayed light in there, right? We've got, I think that's Rhode Island right there, not looking too good. So that's, in fact, if we really look at this, I believe that's the one. If I right click on this and I do properties for selected symbols, I was playing around with this earlier, but we could do that thing, right? Where we have that outline color, hit apply. Yeah. So there we go. That's our one extreme case, right? So that that's a way to really, highlight on that. You might want to do it. You might not want to do it or whatever, but that's something you can do. And you can also, assuming you're playing along at home, you probably got something that wasn't the same as this. What is it? It's this is the one I think it typically defaults to. This god awful, I don't like it. Maybe you dig it. Maybe you think it's beautiful. I mean, it's good for like if you're mapping pollution, I guess, or the 1980s. It's got like early 80s, you know what I mean? That's that. You want to pick something that reflects your data, right? And think about color as you're going through here. Now, number one, these kinds of things, don't do this. All right, this is good for nominal data, or in some cases, continuous data, things like elevation. Some of these with multiple different colors, like these guys here, you use for elevation. But when you're doing it for this kind of stuff, no, you can't tell what's going on. You don't know, is blue bad or brown or the purple, right? It's that dark light that we can quickly figure out. But when we have multiple hues in here, that doesn't quite work, right? So you want to pick what we call these single hue progressions, where it's basically it's one color, right? It's green, but it's light green going to dark green, right? Something along those lines, or what, the pinks or purples or whatever we've got in here. But then you also want to think about what is it I'm showing, right? Most people, as they're mapping this stuff, they like to do this extreme red. And that's good because red, we think danger, angry, things like that. But I do have, let me go back here. Which one is it? I think it's this one. This is looking back, it's, March of 2020 as it was really starting here. This looks extreme, right? But at the same time, it's laughable looking back about a year later at how, like we would kill to have one case, even 24 cases and all of that. So this is clearly early on, but just the red and the big coronavirus cases, just all this big, scary stuff. This is extreme and terrifying and great. And NBC Bay Area here, I'm sure that's what they wanted to go for. But you want to think about, is that what I want to go for? Do I want super extreme? That might work. But if you pick some of these other ones, like blue, I don't know, that calms me. I kind of like this shade of blue more than this shade of blue. So, there's that. That doesn't give it that extreme thing. So think about that. That's why I picked, why I defaulted here. Playing with this stuff. It's still kind of scary, but not as much. But I don't know. You play with it. Okay? But so here, we've got this map. This is a little more accurate in terms of where we got full beds and where we don't. But this does get back to what I was talking about in terms of comparing stuff, right? This is using that natural breaks classification scheme. And so with natural breaks, it's great. So it's why they default to it here. It's great for just spatial data. It's going through, and the computer is doing this. We don't have to do the math to do this. Those poor cartographers in the past, before computers and all this stuff, they would actually have to go through the data, add all this stuff up, do all the statistics in here, and get a sense of, okay, yeah, this is where, my break is actually going to be at 58.7% and then 58.8%, right? They would have to do the math. We don't have to do that, which is great. But what it's doing is it's looking for these natural breaks in the data, spots where it makes sense to stop your first classification and go on to the next one. And what you'll notice is, if you do the math here, they're not equal, or they might look kind of close. It always depends on your data set, but it's never the case where this stuff is broken based on equal intervals here. No, it's reading the data set itself and trying to give you something meaningful in how it's broken down. And you'll also note too that its lowest point is 42.4%, because that's the lowest value in here. It was silly to do 0 to 58, because then you might not know. You might think, okay, like we've got Idaho here, falls into that classification, right? You wouldn't know. Is it, are 1% of the beds occupied or 58%? That can be extra misleading, right? So we stop with the bottom value and we end with the top value, which in this case exceeds 100%. But if every state had hospital bed occupancy less than 100%, it would, let's say 95 was the highest amount. That's where it would stop in here, right? So it's reading the data. Now from here, what you can do is you can decide, you know what, I don't want 5 classes here. I want to do more, or I want to do less. And you can see, you can go up to 32. Don't knock it off. Don't even think about it. Let me show you right here. Let's do that. Do we get something? Maybe. I mean, in some cases, the map kind of highlights some differences in here, but the problem is, you can look at this. I can't tell which one is which, right? Which shade of red. If I put in a legend and I have these 32 different things, I'm not going to know what's going on here. So this 32 I use this. I have little tweaks I do when I'm doing like elevation data, and I want to really show these gradations and have it like look nice and smooth and be more an attractive thing rather than conveying information in a quantitative sense. That's when that can be useful. Okay. And then clearly, of course, like doing one, that's not useful because everybody gets into the same group, right? What you typically want to do is go anywhere from 4, 7 is about the max you want to do here for this kind of stuff. All right, let's hit 7 and see what we see. This is where right here, the human eye starts to struggle to distinguish between some of these values in the middle here, right? Now, what's cool about this is we do see, yeah, Wyoming, you're doing great, right? And we also get the extreme over here of old Rhode Island not doing so great, right? That's the idea. That's what we're dealing with. We have those extremes, but in the middle, it can be kind of hard to figure out where do these guys fit in here and so on. So 5 is the reason it defaults to that is that it's pretty easy to distinguish between these things, but who knows? You're gonna make that decision based on what you're doing as you're looking at this stuff. Is it good to have 4, 5, 6? But that's the range in which you want to stay. Okay, so that's that in terms of classes. But let's get into this. Click on classify. This is where you can change what it's doing. All right, so this is where if you decide natural breaks, I don't like that, I want to do something different, you can make the decision to do something different. And so what that Georgia, those series of maps, what I'm assuming they did was they used the default natural breaks, which can work just fine, but you can't compare a map made with natural breaks for one data set to another map with a different data set that's using natural breaks because those breaks are contingent upon that specific data set, right? That's why we saw the different breaks in those Georgia maps. So what you would want to do is pick something different in here, okay? Okay, quantile, this example, excuse me, this is where each break has an equal number of features. So it's trying to distribute this stuff to make sure that that first classification has, whatever it is, X number of data values, right, displayed. And then the next one gets that same X number of data values and so on. We see this a lot with economic stuff. Measuring, the top quantile and so on would be the wealthy folks. The bottom quantile would be the poor folks and so on. It doesn't quite work for what we're doing here necessarily. I mean, you could do it. We can, like hell, let's do it. Let's just see what it looks like. Okay, it gives us that. Is that useful? Yeah, I don't know. I think what it does is it kind of leaves out some of the, like the obvious, the extreme, lumps that in with some of the others, and the same with the lows here, kind of lumps some of these together. So maybe that works, maybe it doesn't work, right? Or maybe if I change it, if I go to 6, I don't know, let's see, does that do anything? I don't even know if it changed. I think it blinked and I can't even tell, but there you go. It's a way to do it. Might be good, might not be good. I don't know, up to you. Equal interval right here is where instead of getting the same number of values, and that's what this histogram here is trying to show, it's showing the number of cases where we have these values, right? I don't know if that made sense, but it's showing the distribution of your data. Okay, so with equal interval, rather than balancing all of the actual data into equal numbers like quantile did, this is doing, we're going to break it down. Based on the distribution of the data, we're going to have these classification points be equal, okay, as we go through. So it's that same value. That's the idea. And if I click on that, and let's just do apply, there you go. In fact, let's go back to 5. Okay, that doesn't look too different, all right, from our natural breaks, which is kind of interesting. So there you go. That might work. But what's good about this in here is that with this equal interval, it can help you kind of make sense, like especially when you're dealing with percentages. Not that it's the case here, but sometimes it's useful to have like 0 to 25%, 25.1 to 50%, 50.1 to 75%, 75.1 to 100%, right? These are things, breaking it down into quarters, basically, right? Kind of helps our brains work in that way, if it works for the data, of course. So that can be useful depending on the data. And maybe you want to do that. And in this case, I wouldn't say, you don't want to have 0 to 25 because you'd have nothing in there, right? But if you want to move this stuff around, you can either click on manual and you can start dragging stuff, right? Or if you're in something like this, I think you can still drag stuff and you can see it converts to manual. So you can drag here, which is a pain. But what you can also do is just left click once on any of these things and change it in here, right? Maybe I want that to be 75%. Maybe I want this one to be 82%, right? And we'll make this one 90%. Why? I don't know. I'm just clicking stuff. And I can do that, and it'll do it. And that is where it would be useful. This is like with the ranked idea too, but this is the idea where we could have set things in here. So going back to that Georgia map, right? I could have some deal where I could just go, 40% to 50%. I'd have to look at all of my data, get a sense. Do hospital beds ever get below 40%? Maybe they do, maybe they don't. The occupancy rates like we're dealing with here in my whole data series. Who knows, right? But you'd look at that and then you decide, okay, what's my low point that I'm going to have? And then where am I going to cut this off, right? And maybe you have something, instead of saying 103.5%, maybe you have a separate one that's simply greater than 100%, 100% plus, right? But you make a classification scheme that's going to work. And so that way, if you go on and mess with other stuff as you're, getting future data coming in, you bring in that same classification scheme and it's really easy to compare these Choropleth maps. Does that make sense? Hopefully that makes sense. Another thing here, let me just show you one thing I did not, I don't want that one, show you in here, but I'm going to, is in here this, we go back to classify, we've got standard deviation. Okay, and so I hit this and it forces it to 7 right here. Because what it's doing, and you can see it forces this new color ramp on it and all of that. What it's doing is it's not showing you quantities in that same sense as high and low. It's showing you average and then extreme outliers is the idea. All right, so with standard deviation, this yellow here, this midpoint, there's a reason why they give you that 7. So you can have this middle point right here. This is where most of the cases are. All right. Most states around the country fit into this yellow category. And it tells you over here what the number actually is. Right. So that's average based on the states that we're dealing with. Right. And then you can see Wyoming. That's our low right here. In fact, let's just assume. Oh, I can't do anything yet. Let me do this just to kind of look at this stuff and confirm and scroll down. But what was it? It was that 42%. And you can see here too, I did that normalization. You didn't need to do it because they did it for you in the table. So this percentage of inpatient beds occupied estimated, that's what we did with the normalization. So I could have just mapped this raw thing, but then you wouldn't have learned anything. Right? But it's, 42%. So that's on that low end, right? It's 2.5 standard deviations below on the other side of that average. And then we've got this guy right here, good old Rhode Island, struggling. Oh, and that says 89.33. So where's that 103? The hell? I don't know. But it's not Hawaii or... No, I don't. So there's another mystery, right? We go in, we look at our data, try to figure that stuff out, right? In fact, let's look And see, that's important to get a sense of. Let's go to the end here. Total image percentage. Right here, we're going to right click on this. Isn't this fun? Yeah, 89. So where that 103% came from, I don't know. That's a mystery. But you see how misleading that is. Ho ho. So if I put that out there, it's like, yeah, look at, you got people in the hallways, don't even have beds. I'd be lying, right? The worst. Worst it is here is 89%. We could round it to 90% if we wanted to, but yeah, that tells us something, right, about what we're dealing with. This was a good to actually check this, to actually look at the numbers of these outliers. Lesson learned, Mike. But there you go. Hopefully you get the idea. So this is good to show these outliers as well as average in there. It's a different map, right? It's telling you something different. So that's what the point of that one is, as opposed to whatever, our natural breaks, whatever it is we got. So we can drop this back to 5 and see, yeah, that's very interesting. But okay, that's an experiment for another time. All right. Let's see. I know this is going long. Okay, I'm going to show you guys. Yeah, let's skip. I'm going to do the precipitation some other time. We'll mess with raster stuff later. Don't even worry about it. That's fine. What you can do, in fact, what I would encourage you to do to play around with here is, okay, this was that, what was it, the 20th, right? And then as we continue down here, we've got these, future dates. What you can do, select by attributes, is you can go through, okay, it's our collection date. So right here, collection date equals, get unique values, and it gives us our different dates, right? The 20th, 21st, 22nd, 23rd. Play around with it and, grab another date in here. What was it looking like? What would be good to do? Do the 21st. So I double click on that. I can hit verify, make sure I didn't do anything wrong, hit apply. And you can see down here, 52 of, 1,600 selected, show the selected ones. It's just right there. Okay. Now what I can do, you can do multiple versions here. In fact, what I would always do, just to keep it simpler, is I would right click on this table. Okay. Go down to data, export selected records, right? You could do all records, but that's going to give you a copy of the same table. But selected, right? And I'm going to find a place on my computer where I know where it is. I'm not going to call it export output. I'm going to call it, hospital beds 121, something like that. Not putting any spaces, not any crazy characters in there. And then what I do, and I say I would fix that. I'm just going to do this real quick. No, there's an error. Okay, well, that's why I would be very careful with this stuff, depending on where I saved it. But you get the idea. When you do that, bring it in. I could copy this, right? I'm just going to make a copy of that. All right, let's just go up here to layers and paste. Okay, and so with this one, in fact, I'm going to remove joins, remove all joins from here. Let's close this. I'm going to call this, what was it, Jan 2020. Keep that in mind, but then I got this other one. And so when I get that exported one, bring it back in, I join it here, and I can make these maps, and I can compare them. I can see the issues with if I leave it at natural breaks or if I actually have some kind of manual scheme that I plan out, right? And then if I really wanted to, if I wanted to suck up to my professor and show off or just play with it or whatever, I go into layout view, right? And you could have little box. You guys did this in 205 where you can make little separate data frames for Alaska and Hawaii, have those separately. But you could have, ho, right? I could have this guy here, up here. I could do insert, data frame, get something new, right? Oh, I got to do this. I just clicked and dragged that guy there, right? And so I could have that, and I could have, put in a text box. I don't have any of my stuff on here, but I just right clicked up here, got the draw thing. And so in here, I could have the text that says January 20th, right? And I could have multiple dates. This one would be for the 21st. So in here, I do that, and I do Jan 21st, and I make it look all pretty, right? I'd look at this January 20th one, and I would go, oh my God, look at that dumpy geographic coordinate system. I'd go into properties in my new data frame. I'd get out of this geographic nonsense, right? And get the same projected one, whichever one I was using initially. I can't remember. Let's just say it's that one, and I'd hit apply just so it looks good, right? But I'd make sure I'd pick the right one for all this stuff. And you could have like 4 different days, and you could show progression, or you could do it, right? Like not just the 21st, 20th or like 24th or whatever, but I could do the 20th, and then I could do January, 30th, and February 10th, and February 20th, if it goes that far. Or whatever, right? Every 10 days or the weekly progression or something to see if there is a trend. That would be something cool to do if you want to do it. I'm not going to do it. I've been talking for too long here. I got other stuff to do, right? Other classes to play around with and all that. But you could, and that could be pretty sweet. All right, geographers. So there's a little bit about mapping quantities in here and some pitfalls and all of that. Play around with it. I hope you learned something, and I hope you, having watched this, don't make some horrible map that winds up getting people killed in the next pandemic. No pressure at all. Best of luck. All right, talk to you later.